Hello there, this is Wellington with PX5, and today I'll show you how to work with semaphores using PX5 RTOS. So in this video, we'll run through the semaphore APIs, then I'll run a quick 2 minutes demo, and then I'll share some resources. Semaphore is another synchronization object, and you'll also see semaphores being used to control resource access, and while possible, we recommend using mutexes for that. So basically, semaphores are counters where non-zero values indicate availability and zero value indicates the semaphore is not available. The thread may block when trying to get a semaphore with a value of 0. Then, once the semaphore is released, the highest priority thread will resume. Also, ISRs can post to semaphores using the SemPost API. There are plenty of semaphore APIs, so make sure to check the PX5 RTOS user guide to get the full list. So before we can use a semaphore, we first need to initialize it. We do that by calling the SemInit API, passing the handle of the semaphore to set up. Also, the process sharing selection, which is not used by PX5 RTOS, and then the initial value of the semaphore. It can be 0 if you want. And then we check the return for errors. Then, once created, we can post values to a semaphore using the SemPost API. And to do that, we just need to pass the handle of the semaphore to post. If one or more threads are waiting, the first thread waiting will be resumed. Otherwise, if there are no threads waiting for the semaphore, the internal semaphore counter will be incremented by 1. Then we check the return for errors. If the semaphore is available, counter greater than 0, this service, the SemWait, will decrement the semaphore count by 1 and return success for the caller. Otherwise, if the semaphore is 0, the calling thread will suspend until the semaphore is available. The semaphore wait API only requires the handle of the semaphore to get. In the samples we'll be showing today, there are 2 threads working in a consumer-producer arrangement. Main thread will create and post to the semaphore, while child thread will be waiting on the semaphore and taking from it once it's available. Let's see these APIs in action. As always, main start running and creating variables, thread handles, and memory area. Then, in line 5, we start PX5 RTOS by providing a random number for pointer data verification. We see what that is in a separate video, the memory area, and the size of that memory area. At this point, main will be converted into a thread running with the default priority for PX5 RTOS, or 16. Next, we'll create a semaphore, passing the handle for the semaphore, a process sharing, which is not used by PX5 RTOS, and the initial value of the semaphore, in this case, 0. Notice now we have the semaphore created, and it is empty. Next, to create another thread, all we need to provide is a handle to the thread, and then the entry point for this new thread. Now, as you can see here, we have child thread created with its standard, also with the standard priority of 16, the same as main. It's ready and waiting to run. At this point, main will yield, allowing child thread to run. So now child is running, and it will increment the counter, now at 1, and then it will try to get a semaphore. But since the semaphore was initialized empty, child thread will be suspended until the semaphore is available. Like that, we return to main, which will increment its counter variable, and then it will post to the semaphore. But notice, because we have a thread that is blocked waiting on that semaphore, even after posting, this value won't show on the semaphore. Like that. So now child thread is no longer blocked, but it won't preempt main because they have the same priority. Now main will yield, allowing child to run. Child thread now resumes and it will increment its counter, now at 2. Then it will try to get a semaphore again, but it won't because this is empty, so the child thread will be suspended allowing main to run again. Main will increment its counter, post to the semaphore, yield again, and the cycle goes on. That's the demo we had for today. As always, if you want to know how to get started, make sure to check our website at PX5RTOS.com. You can email us with questions, requests for information, or a quote at info@px5rtos.com. Thank you for your interest.